Good morning. My name is Marta Waczyńska and I will present an article entitled Daylight Appraisal Classes for Architecture Students. This paper aims to formulate guidelines and recommendations on daylight evaluation methods and tools for architectural training in context of Polish architectural education. To begin with, in Poland, 34 educational institutions offer architecture courses for students and graduates. Out of 5 top universities, only one offers mandatory training in advanced lighting design. What follows, the subjective and objective daylight analysis, is not a mandatory part of architectural training in Poland. In addition, sunlight assessment and insulation training are offered as a part of the non-mandatory courses by various architecture-related associations. The first aim of the study was to investigate the relationship between the students' subjective assessment of daylight conditions in classrooms and the objective evaluation using simulations. The second objective was to formulate recommendations and guidelines to support daylight educational content for architectural courses. The methodology applied in this paper followed the sequence of steps. After the introduction mentioned before, the first step was a direct questionnaire conducted among 194 architecture students in 3 universities located in 3 different cities in Poland during 30-second sessions under various sky conditions. The second step was computational daylight simulations conducted for each of the sessions. The third step involved a comparison of the results obtained using 2 methods, followed by formulating the general conclusions on methods and tools used. The questionnaire was designed to learn about the students' knowledge on daylight parametrization and normalization and to highlight the possible gaps in Polish daylight education. The students who took the questionnaire were asked to evaluate the daylight conditions within the given space and answer quantitative and qualitative questions about their personal preferences in categories presented on the left side. This article is focused on selected 3 specific questions regarding daylight conditions in classrooms, sufficiency of lighting, daylight uniformity of task illumination. The questionnaire took place between 2014 and 2017. The sessions took place at different times of the day and under various sky conditions. The students' daylight evaluation results were compared with the daylight simulations conducted for all the classrooms. The simulations were conducted using Rhinoceros 3D and Diva plugin. There were conducted 3 analyses: daylight factor, spatial daylight autonomy, and illuminance. The geometry and parameters of the spaces are presented in the table. To investigate the overall daylight conditions in classrooms, there were spatial daylight autonomy analyses conducted for all the localizations. The highest overall values of spatial daylight autonomy, about 60%, were obtained in selected rooms in Gdańsk, sessions 4 to 6, with an exception for session 1, an attic classroom with small window openings. The spatial daylight autonomy results, around 40%, were received in classrooms addressed in Poznań, sessions 10 to 12. Significantly lower values were acquired for sessions in Sopot University. The obtained results of the participants' perception of the daylight conditions and the simulation results were presented in charts. The mean students' appraisal for each session have been complied with the mean values of the chosen daylight metrics, daylight factor or illuminance. The choice of used metrics was dictated by their presence in European recommendations and different computational design tools also used by architecture students. The responses to the first question, how sufficient is lighting in the room, has been compared with the mean values of the daylight factor. All participants' responses were between the sufficient and not sufficient ranges. The classrooms with the most sufficient lighting, according to the responders, were rooms analyzed in sessions 2, 11, and 12, which were carried out in the afternoon under clear sky conditions in rooms with west orientation with a good view out. These factors combined result in the high subjective evaluations of daylight sufficiency. The insufficient perceived lighting levels when reported in classrooms in sessions 9 and 13. The biggest differences in values levels obtained by 2 methods were noticed in sessions 1 to 3 and session 8. The authors suspect that these fluctuations might be related to the spatial complexity of the classroom, session 1, or a large number of different window openings, session 2, 3, and 8. To sum up, these results of subjective daylight appraisals correspond well with the simulation results. The responses to the second question, how would you describe daylight in this space, have been compared with the mean illuminances value simulated per each classroom. The majority of the responders evaluated the daylight as medium in almost all investigated classrooms, with exception to the session number 13, which obtained the lower poor rating. The highest overall values of illuminances were in the range from 420 to 460 lux, were obtained for sessions 2, 10, 11, and 12, carried out in Poznan in rooms with 40% of SDA values. The question number 3, what is the uniformity of task illumination, result, were confronted with the mean illuminance levels simulated for each of the classrooms. The uniformity of task illumination was rated as medium by the responders for all the analyzed spaces. The classes with the best perceived uniformity levels, majority answers close to good rating, were collected in sessions 3 and 9. Both rooms have east exposition. There were significant differences in subjective perception results and simulated values for sessions 10, 11, and 12 for classrooms located in Poznan. The highest illuminances were not associated with the best uniformity appraisals. The most important results of the daylight evaluation part is the fact that the subjective participants' assessment of the observed daylight characteristics agrees well with the daylight factor simulations in 9 of the 13 cases, but there are no significant correlations with the mean illuminance values. The subjective perception of uniformity was rated as medium at all cases, while the mean illuminance levels varied from 60 to 40 and 460 lux. The key findings in the architectural training part is the fact that daylight analysis and the simulation tools can only be taught effectively if the students have a basic knowledge on daylight and simulations and can understand and relate the generated results. Furthermore, the contemporary computational daylight evaluation tools can be taught in a context that is familiar or used by students. Thank you.